Welcome to the office. I want to make one more statement of a theorem that is included in this section on permutations, the group of permutations, or groups rather, right? For a different set, we'll come up with a different set of permutations, set A, permutations on A, different groups. Anyway, so if we have a group, so just some group, any group, whatever group you can think of, okay? Take that group. It is isomorphic to some group of permutations. Now, what it might actually be is if we think of like S3 from our last video, which actually we'll take a look at as an example in class as well, kind of an activity there. What we're going to do is we're going to take, we can take a S3 as the entire set itself. It has 6 elements, right? 3 factorial is 6. There's 6 permutations on 3 things. We might have that the group that we're thinking of, it gives us exact isomorphism to S3 itself. Or what it might be is that that our group is isomorphic to H, which is actually a subgroup of Sn, right? So we can have this sort of situation. G, the group that we're considering, can be isomorphic to Sm, the entire symmetric group, that's fine. Or we can have that G is isomorphic to some subgroup. Now, this has some really weird implications because we certainly have things like abelian groups, right? Abelian. Well, we know that function composition is not commutative. Therefore, in general, Sn is not abelian. So if I have an abelian group, it certainly won't be isomorphic to a non-abelian group. However, we might have an abelian group that is isomorphic to a subgroup of this non-abelian group. Okay, so we can have subgroups that are abelian, which is kind of cool. Okay, all right. That's all that I wanted to share for this video. Every group is isomorphic to some group of permutations, and that's it. There is a proof of this in the book. There are a couple of definitions that are given. I think it just goes into things a little bit more than we need to at this time. So we're just going to call it good and move on to the next section. So thank you for your time and your attention. Have yourself a wonderful day.